The topic is really big, and I was thinking about how exactly to like go about doing doing this, because it's really, really context specific. Like you'll encounter so many different things, and there's different ways of debugging based on how like what you're doing. So I'm gonna try to cover some of the basic stuff and then work into some of the more common things that are encountered, and then some ways of preventing bugs from happening in the first place, and then getting into like more formal debugging stuff. So, the very first thing I want Noria you to do is I want you to create an R script. So you can do that with file, new file, R script. So normally I always get people to make a R project. Like anytime you're doing a project in R, you should always make an R project. But because in this particular case, it's not that important. And if you want to see how to make the R project, there is a YouTube, I think, of one of the first sessions going over how to make R projects. But in this case, we don't need an R project right now. But what I'm going to just cover is the first step to debugging is understanding the error message. So that's usually the hardest part. And I want you to do something simple like, I think this should work. Do sum and open close bracket. C, the letter C, open close bracket, quote, like the quotes character.
What's the quote?
Yeah, double
Like
quote.
this one. Okay.
Yeah, there you go. Yeah. Let's do A, and then go outside the quote, and then do comma, and then do another quote, and then do B, and then I think this should, and then do Control Enter. So one of the very first things is I'll just like explain this a little bit. So like C, the function C is a way of combining or like making something into a vector, and sum is something that, as you can kind of guess, is like a thing that calculates the sum of numbers. Right now, you're like it's relatively easy to see like you can't calculate a sum of letters. We know that intuitively, but the thing that I want to focus on here is the error message. Oftentimes, the error message tells you what the problem is. It isn't always like very explicit about like it's not very clear what the problem is, but oftentimes it'll give you a hint of it. And many beginners, they see this like red and they think, oh fuck, I don't know what's happened, and then they freak out. I could tell you from experience, like seeing error messages is extremely common. Like you're going to be seeing these all the time, no matter your skill level. So getting used to the fact of like seeing, oh, there's an error, then reading it. So the very first step of debugging is reading the error message. Now here we can see the error message is, it's not very clear, but it's saying it's invalid type. And then it gives you a little hint of saying it's a character. So that tells you something, okay, what you're trying to do isn't working for this sum thing isn't working with characters. So you can kind of get a little bit of a sense of the issue. Let's do one more example. So let's create a new line and do paste, open close bracket, and then should I do paste or do I want to do something else? Yeah, paste is good. And then do quote, and then type out hi, and then go outside of the quote, space,
Paste again?
the space bar,
Space. Sorry.
quote, and then say, what's up? Now you can probably maybe already guess like what the issue might be here, but when you run that, you're going to get like this like, so the reason why I want to highlight this particular one is the biggest issues that you're going to encounter when debugging is you forgot a comma, or you forgot a bracket, or you misspelled something. So in this case, we forgot a comma, but we don't necessarily know that right away. So there should be a comma between hi quote and then comma quote what's up. But I don't want you to do it just yet. Unfortunately, the error message isn't helpful in this particular case because it says unexpected string constant. And it's like, okay, what does that mean? We don't know. Like I personally don't know what that means. And neither does R, because R doesn't know what you want from it. It doesn't necessarily understand that you're wanting to have a comma in between there. So usually the second step of debugging is reread your code. So we have an error, then we go back and we say, okay, let's look at the error message here. Let's look at the code, I mean. The code is hi, and then what's up. Knowing a little bit about the function paste. So actually, if you with your cursor, go hover over paste and press F1. I think you might have to do
with control
function F1. Function F1. Are you on a Mac or no? You're on a Windows.
No.
Function F1. So there's this little thing that says FN in the corner. Okay. There we go. So what F1 does is it sends you directly to the help file of the function. And that's something that, yeah?
It would be the same as if I put like paste.
Yes, that would be the same as doing there, yeah. But it's a little bit faster when you're like just from point of view of like tips and tricks on how to become better is doing F1 while inside of the function.
Okay.
And so oftentimes you can get a sense of what the issue is by looking at the help documentation. And here, the very first thing that we see is where it says paste ... So that paste ... comma means it accepts multiple functions to paste stuff together, to combine things together. But what this ... means is you need to have a comma after every single item. So in this case, we need to have a comma after hi quote. So if we go back to paste and comma, and then if you run that, now that should work. So that's the other thing of debugging. And these things are like sort of basic level, and we're not getting into any formal debugging, but these are some of the very first things that you'll be doing when you encounter some issue within code. The next issue is a little bit trickier to deal with. So I want you to write out library, open close bracket, and we're going to use the pipe package Magritte. So MAGR, that one. Then run that one. And then I want you to use, there's a built-in data set called, let's do CO2. So capital C, that one right there. Mm-hmm. Yeah.
So what I presented.
So enter. And then pipe. So go to line 4 and pipe. So add a pipe by doing Control Shift M. Is it Control Shift? Yeah. Control Shift M.
Done.
and then type out filter. So right now, what we'd like to do, like let's say hypothetically, what we want to do is we want to find all of the I think plant type of let's scroll up on the R console in the R console.
What do you mean? Scroll.
Yeah. Okay, so let's say we want to see the concentration like or the uptake, any uptake that's above 30, let's say. We're interested in what uptake is above 30. So we would select rows that uptake is greater than 30. So we do that within the dplyr package with filter, and that subsets rows. So we'd say uptake greater than
Like
30.
okay.
Yeah. Then control enter. Okay, so this is an issue. Why you encounter a problem, and it's saying object uptake not found. So you think, okay, why is that the case? And this is one of the second big things with so within R, there are several things that are extremely powerful and useful, but from like a programming point of view are not very well designed. And one of them is that anybody can write a function called anything else, and if you load them all together, what happens is some function names can be overwritten. So in this particular case, we aren't using the function from the dplyr package. We're actually using another function. So if you hover over filter in line 4 and do F1, you can see in the top corner where it says filter stats. So see in the top corner, filter stats. That stats is the package. What we want to be using is the package from dplyr, or we want to be using the package dplyr. So the error here is because we are trying to run a function that doesn't do the same thing as what we think the other function does, which is dplyr's function, because they both do different things. The stats filter does something different than what the dplyr function does. And this is a thing called like a namespace issue, because there's two different, well, right now we don't have two different ones, but we think we're using one function when in fact from one package, but when in fact we're using a function from another package. And this can occur a lot when you have a bunch of packages that you're loading and you don't necessarily check to make sure that some of the functions are being overwritten or not. So let's do library. So create a new line, library, dplyr, and then control enter, and then control enter. This is library failed and is being loaded, but okay. So this is a great example of another issue that might occur. So right now, I think the package Navigator is loading a package called rlang. So if you look in the error message, it says package or namespace load failed for dplyr. In load namespace rlang is loaded, but 1.1 is required. So this tells you that one of your packages is needing a version of another package that is higher than what is currently being loaded. This sounds a little like high level, but when you see an error like this, one of the easiest things that you can start doing is loading the packages one by one. So since we've already loaded all the packages, we need to restart the R session. So restarting R is another common thing that you will be doing when you're debugging. So what we do is we go session in the session, restart R. Click it. Now we have a clean slate again. So what we want to try to do this time is not run Navigator. We delete line 3. And the advantage here is that dplyr already loads this package internally. So if we run this by itself, we get another same error. So we get the same error, even though we've restarted R and just loaded it by itself. So what that's saying is we might need to reinstall this rlang package. So what we can try to do is go install dot packages quote rlang.
Which one? Dplyr.
The package that's called read the error message.
Erlang, this one.
Yeah. Rlang, yeah. And then go outside and do comma. Inside the bracket, but outside the quote. One more over. Yeah, quote. Force. No, sorry, not quote. Not quote. Force equals true. All caps, yes. So what this does is it'll force a reinstall of this package. So let's see if that works. So click enter. And then restart R.
Okay.
And then try to load dplyr again. So now we have another issue, and it's probably the same thing. So we try to do the same thing. So go to the R console, and then click up, and then go over and replace rlang with vectors. So you see how like it looks a little scary, all these like stuff, but as long as you start saying, okay, there's this package that says it needs a certain version, and then see, now it works. So it's just about reading the error message and then saying, okay, there's something about this package, maybe I need to reinstall it. So then you try reinstalling it. So then now when we run line 5, it should work. There we go. Now nothing is below 30. So that's a namespace thing. So the one thing, what I want you to do is now, when, I don't know if you maybe have this package, but we'll see. When you don't know if a function is being replaced from another package, there's this other package that lets you find out whether or not a function is being replaced or not. So let's go to line 6 just so that we can have it included there, and then do conflicted. So CONFLICTED.
This one?
Conflicted. Yes, that one. And then do conflict, CON, and then select the one that says scout.
This one?
Yes.
Okay.
So what scout does is it'll search for all functions that have multiple names in different packages. So if we run this, we see here it says that there's 2 conflicts. So there's a function called filter that is in both dplyr and stats, and there's a function called lag, which is in dplyr as well as stats. So what that means is when you load dplyr, the stats function will get replaced. So you can't use it anymore. If you want to specifically use the function from filter or the function from stats, what you do is you do stats. So type out in line 7, stats, : filter. And this is a way for you to be very clear. I want to use the stats. I want to use the filter function from the stats package. So if you ever encounter some like issues related to this and you want to be very clear, I don't want any other function to be used, this is the way that you would do it.
Okay, one question, look. This is the conflicts that I have in all my packages, or only the R script?
Only in the ones Yeah, only in the ones that is being loaded right now.
Okay.
So if we were to load like a bunch of other packages, we'd probably find a lot more conflicts. But these are the only ones that are being actively overwritten right now.
Okay.
Let's get into the next thing, which is kind of relates to sort of this topic. So because making functions in R is so easy and like you really should do it as often as possible because it is something that like this is the way that R is built and making functions isn't that scary. Let's make a function where we say we want to maybe drop numbers or drop up the subset. Let's say we want to subset this is already done, so it's going to be kind of a dumb thing. But let's say we're going to subset CO2, the CO2 data set. So what I want you to type out is fun, so FUN. And then there's a thing that automatically pops up called snippets. And I think we covered snippets in the last session, actually. But these are like ways of quickly adding code that allow you to include a skeleton of some code. And in this case, this creates a skeleton of making a function. So here we want to write subset underscore.
In the name?
Yeah, in the name. Yeah. Subset underscore CO2. Yeah. Let's do all small cases because we want to be consistent with the snake case. Yeah. No, it's. Then in the variables section, we say filter underscore condition. We could probably make it a little bit shorter, but that's fine. Then inside here, we want to write filter, open close bracket, CO2, capital C, capital O, 2, comma, and then space, filter underscore condition. Then we create a new line. Create a new line after line 12 or after line 11 now. And I want you to first restart the R session. Yeah. So then now here do subset underscore CO2 and then open close bracket. Uptake is greater than 35. Now, before running this, can you kind of guess what's going to happen based on what we talked about previously?
Maybe it's not going to use the right function in the right package.
Exactly. So let's try running line 9 and then running line 12. There we go. And you're right. We encounter that same issue. So what you do, normally a good practice when you're writing functions is once you're finished writing the function, you explicitly say what package each of the function comes from. So in this case, let's write dplyr, : filter. Yes. So then now on line. So the thing that you did here, so this is another thing. The thing that you did is that you ran a line inside of the function. But what you want to do is you want to run the function, not what's inside of it. So sometimes you'll get that error, and that's probably because you actually need to run the function itself, not this thing. So let's now try running this. Now we have an issue. In argument, filter condition caused by error, object uptake not found. So that's kind of weird. I mean, you know that the object uptake is inside of the CO2 thing, the CO2 data set. So that shouldn't be an issue. It's there, and you're using the right filter.
Yes.
So what's exactly going on? So the way to debug functions is a little bit different. And the way we do that is by using a thing called either debug once or browser. So I'm going to first cover debug once. And what you want to do is type out debug once, all one word.
This one?
Yes, that one. Yeah. So what this function will do is you'll give it another function, and what it will do is it'll only debug it one time, and then after that it won't debug it anymore. There's a similar function called debug, which will always debug one function, but in this case, like that can be kind of annoying. So like let's just only do this one. So then inside of there, type out subset underscore CO2. Yes. Enter. Control enter. So then now let's go back to line 12 and control enter that one. So what happens here is we enter debug state. So this is the formal way of debugging code inside of R is through this interface. And you'll see like there's a couple of things on the top there inside the console. It says next, it says continue, it says stop. Do you see that, Núria? Yeah,
Yes.
exactly. So what those do is it goes line by line. Like if you click next, it'll go line by line inside the code. So before you continue, I want you to go to where's your environment?
Good question. Here.
There it is. So the thing is that the environment will be only what is contained within this function. So you can already see here right now, there is this values called filter condition with uptake underscore uptake less than or greater than 35. That's what's going to be present. You see it's grayed out. That means it's not yet present. And it's just waiting for it to be used. So it's saying this thing exists. Nothing has been done to it yet, but just letting you know that this thing exists. So then now if we click the next button, it'll throw the error. So we're like, okay, so we were already in there and we saw like there was something like it kind of existed. So what we can do is if you consistently have like issues with debugging, the way to fix a function until it's finished is by using the thing called browser. So inside the function, so create a new line above line 10.
You mean inside the function?
Yes, inside the function. We're gonna call the function called browser. That one, yes. Open close bracket. So what browser does is when you run the function and use it, it will place your debugging state exactly at that line. So if you had like 10 lines of code inside of a function and you put the browser in the middle, it'll go to the middle point. So this is really useful because then that way you can go exactly to where you think the problem is, and then you can start debugging from there. Since ours is only one line of code, we can say we'll try to fix this issue right from the beginning. So now go to line 9 or line 12 and control enter. Now we do control enter again. And so it immediately puts us into this debug state again.
Oh.
So here we can click, before like continuing, we go to the browser and we know that there's some issue with uptake. So if you go into the browser,
how do you know that?
If you go into the console,
Yeah.
and type in the bottom and type out filter underscore condition and then enter. So here we see right from the beginning, we see that our condition that we are giving to this function isn't coming through. So the issue isn't with the code inside the function. The issue is with the code outside of the function. Now, this is something that's a little bit special with a lot of, again, this is something that's special with R in particular, but also within the tidyverse, is it makes use of a thing called non-standard evaluation. So what does that mean? Non-standard evaluation is if you type in the console, type out library, and then open close bracket. In other programming languages, you would have to do quote. So type out quote, tidyver. Let's do dplyr, enter. So if you remember from other ways of loading dplyr, we can also do the other way, which is library. So type it out again. Library. Without quotes, dplyr. Enter. So this still works because even though we get a warning message, but the warning message is not related to anything, the difference between using quotes and non-quotes doesn't matter in certain cases in R. But in other programming languages, if you were to do something like this, you would have to use quotes. And quotes is what is called standard evaluation. In R, when you don't use quotes, that's called non-standard evaluation. And you might see this like this it's like oftentimes like computer programmers or computer scientists will see R and be like, oh, this is really weird. Like, why is it doing that? But it's because R was designed by statisticians, not by computer scientists. And this non-standard evaluation is really useful when you're writing statistical code. Because if you want to write a model, like for instance, like a formula where you want to find like a model where you want to find the influence of body mass on risk for diabetes, let's say. In the model, you would use like diabetes is equal to body mass plus, age plus whatever. And you can write that without the quotes in like a nice clean way. But this also means that we encounter a lot of issues when we want to write code because we're using standard evaluation, non-standard evaluation, when R often needs standard evaluation. Yeah, did I say that right? Non-standard evaluation when it's looking for standard evaluation. So within the tidyverse, so if we go back to the script, there. So within the tidyverse, if you remember from the code above, or if you go back to your script, and if you go to line 5, if you look inside the filter, having just said what I said about non-standard versus standard evaluation, what is this code right here? Would that be non-standard or would that be standard?
Non-standard.
Non-standard. Why do you think?
Without the quotes, it's non-standard, right?
Yes, and it's because when you don't have quotes, an object without quotes is interpreted by the program as an actual object. So here, without dplyr using its non-standard evaluation internal stuff, R would interpret uptake as an object because it's not quoted, right? We don't have that quoted. So R would think, oh, you're looking for this object called uptake. But uptake doesn't exist. It only exists inside of the data set. So in order from a programming, like from a data analysis point of view, this is really useful because imagine if you had to like always do quotes for everything like this, like that would be really annoying. But within the tidyverse, they've made it like simplified where you can just type out like uptake is less than 30 and you don't have to do like quotes and all this other stuff to fix the thing. But what that means is you have to find some way of saying this thing that I'm using inside my function is non-standard evaluation. So don't interpret it as standard evaluation. Thankfully, there's a way to fix that. So if we go to click stop,
Do I press?
yeah, yeah, press stop, and then go to your function, and inside of the function, right before filter, yeah, inside the function, yeah,
Here.
to curly, like the curly bracket twice. So this thing is called curly. So curly bracket,
What
I
do you
think
mean curly bracket?
it's it's you see at the very end of the
This
function
one.
is a curly bracket.
Okay.
Yes.
I need to copy because I have the Swedish keyboard and I don't know.
So now do it twice.
Like here?
2 times. Paste twice.
Okay.
Yeah, and then paste twice at the end. I think on the Swedish keyboard it's Alt G7 and Alt G0.
Yeah, no, it's 7 and 9. Yep, okay.
Seven,
now I
nine.
have the Swedish keyboard. I mean, I had it in Catalan and I don't know where is it in Catalan. But yeah, so.
Okay, fair. So now what this like curly does is it says what you're inserting into this dplyr function is going to be it's going to be treated as non-standard evaluation. So it's going to be put into there. And if you run it now, so if you do on line 12, run, and then line 13, run. And then when we enter here, you click next, and then click next again. It works. So we can even test it out again and do, let's do, instead of uptake, replace uptake with concentration. So CONC.
Here?
Yeah.
Copy again.
Yeah, exactly. And then CONC without the whole. It's just
Okay.
That's how the function. That's how the
data set. Yep.
Yeah, exactly. Then we can click next. Click next, and that works as well. So everything is basically greater than 30. So we'd have to do something like 500 or 600 or something. But so before continuing, next.
Okay, sorry.
Yeah, it's okay. Now you see that it's higher. So now that it works, now you can delete line 10 and rerun the code. So line 9 and run it. So now we know that it works. So like what I've just sort of like talked about are some of the, at least for myself, some of the most common things that I encounter when having to debug things. And it's also stuff that I often see other people struggling with when it comes to this. But the debugging is the browser function is an extremely useful tool to use to figure out what's going on. And like, so this whole like non-standard evaluation, when I first encountered it, I spent months, maybe not months, but definitely like a month of trying to figure out what the fuck was going on with my code, because I had no idea. I didn't understand what was going on because I hadn't learned what non-standard evaluation was until later, when I finally figured out what the problem was, and then I realized it was non-standard evaluation. So hopefully, just with this basic stuff that I've shown here, you can fix most problems, like most common problems, at least that I've encountered and that I see other people encounter. I think I don't have anything else. I think that's probably good enough for now. Debugging is like a huge topic, and it's really, really dependent on your code and what you're doing. And I used to, in the introduction course, or no, not in the introduction one, in the intermediate course, I think I had a section on debugging, but it's just really hard to teach because it's really, really dependent on your code and what you're doing. And um, the best way to figure it out is to like use the browser, read the error messages, and then also use Google,
Do
like
you
copy
have
paste the error messages. Yeah.
do you have like a favorite like blog or place in internet where you find all the answers, or you just paste the error message in Google and see the options?
Um, I would say like Stack Overflow has a lot of
Mhm.
good help. That's usually what I would go to first. The unfortunate thing is that oftentimes a lot of the answers are like quite old, so they don't necessarily might not necessarily solve your problem right now. Um, what else would I use? Yeah, I would say those are the biggest thing that I use, Google and then Stack Overflow.
Mhm.
Yeah. But anything that anybody wants to add or like is maybe confused about, or I mean this debugging is confusing. Like there's zero doubt about it. It's a confusing thing. So if you're confused, that's totally normal. Totally fine. You just get used to being less confused. Well, you get used to being confused. It's a normal state of things, basically. Yeah.
Can you hear me? Hi.
Yes. Hi.
Hi. Um, I mean, this is not directly related to debugging, but the other thing with the non-standard evaluation, because you perfectly described my feelings as well with the encountering them for the first time and not knowing what it does. But for me, it's
Yeah.
very, and I'm not sure if I ever got it. But like, aren't there different concepts around right now, like with the double bang, with the bang bang, and like I'm a bit confused. What is the one that works all the time, or works only tidyverse style, or is there like a good guidance on that, or what? I mean, do you also only use curly curly now, or is that?
That's a really great question. So, yeah, for the longest time, there were different solutions for this problem. Um, and it was, I think, like only recently well, recently, like at least like the last couple, like 2 or 3 years, the curly curly came in, and curly curly is developed within the Rlang package, that package that we had to reinstall. Uh, so the Rlang package implements a lot of like underlying R, like basic R things in a cleaner, easier way. So the way that you would originally have to like solve the non-standard evaluation way was you had to use like 3 or 4 different functions in order to like properly use it. So from a programming and user friendliness point of view, it was a pain. And even not that long ago, yeah, like as Fabian, as you've mentioned, like there was the bang bang, which is the exclamation mark twice. You can still use that actually, and that is used in different circumstances. So I know if you use bang 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 like three like exclamation marks 3 times, that allows you to do something that's slightly different than, but it is still kind of like a non-standard evaluation thing to bypass the non-standard evaluation. Um, I would say for the majority of cases, curly curly is the best solution within the tidyverse. Outside of the tidyverse, it's a little trickier, and you'd probably have to use base R stuff. And I feel sorry for you if you have to do that because it is painful. I This is a big reason why I make use of tidyverse packages quite a lot, even when I'm developing my own code and like packages, because it just makes even developing easy. So yeah, I would say as much as possible, make use of dplyr and curly curly if you're encountering a non-standard evaluation problem. curly curly is by far the easiest of the iterations that have happened so far. Yeah, it's been basically like there was the base way of doing things, and then Erlang came around, and like there were three different versions of it. Like first generation and the second generation, and now the third generation is the curly curly. And I would say the curly curly is the easiest for working with non-standard valuation stuff. I hope that answers the question.
Yes, also validates my feelings. So
Yes, believe me. I mean, even before curly curly was around, like, it was really extremely difficult to understand conceptually, and then to try to debug it was even more of a pain in the ass. So, for all you beginners there, using the curly curly brackets, you have an easy time. You definitely have an easy time relative to what it was like before. But yeah. So it's almost been an hour, and what I guess I can say at the end, if nobody has any other comments, then the next session I think we'll try to aim for same time, but on January